We continue the lesson. As I mentioned to you yesterday that we will be studying all this reaction. So today we will touch on the first one and the third one. Combustion of metals with oxygen and chlorine, changes of Fe2 ions to Fe3 and Fe3 to Fe2 ions. You're just going to study the redox reaction among them. So meaning you're going to identify which one goes through oxidation, which one goes through reduction. The pages that I'm teaching you today is actually the one from page 397 until we will try to cover until page 401. So later you read the textbook, but I'll just show you a brief explanation which is much more easier. Okay, so we're going to cover these two. Now the first one, combustion of metals with oxygen and chlorine. So let's say we take sodium metal reacts with oxygen. What will you get? You will get sodium oxide, right? Okay, balance your equation. So if you here got 2 oxygen, right? So now 2 oxygen, okay, 4 sodium, 2 oxygen, 2 oxygen. Equation is balanced. Now I want you to tell me which one went through reduction, which one went through oxidation. First, you just identify the oxidation state. That's the most easiest, is to identify the oxidation number. What's the oxidation number of sodium? Sodium is a pure element, so the oxidation number is 0. Oxygen molecule, oxidation number is 0. Sodium, here it's actually sodium ion. This one is actually oxygen 2 negative. Okay, can? And since there is here 2 sodium, so it's actually 2 plus, here is 2 negative. Okay, so if you notice, sodium from 0, the oxidation number changes to plus 2. Is that an increase in oxidation or decrease in the oxidation number? It's an increase, right? If it is an increase, that means this one has gone through oxidation. Whereas oxygen molecule, if you notice, from 0 it changed to 2 negative. There is a decrease in the oxidation number. So meaning this one has gone through reduction. Which one is the oxidizing agent? Oxidizing agent will be this one, because oxidizing agent means oxygen molecule oxidizes sodium to sodium 2 plus ion, but itself reduce. So it's exactly the opposite. This will be the oxidizing agent, whereas this one will be the reducing agent. Sodium atom reduces oxygen molecule to oxide ion. It's exactly the opposite. So the first thing is, when you get an equation, you balance your equation, do all the normal stuff. Once all that done, first thing is always try to write first all the oxidation number. After you write the oxidation number, from the reactants you see which one went through oxidation, which one went through reduction. Then you determine the reducing agent and oxidizing agent, which is simple. It's exactly the opposite. Okay, can? Now we already know which one oxidize, which one reduce. Sometimes the question will ask you to write ionic equation, or they'll ask you to write half equations. So how do you write half equation? How do you write ionic equation? Half equation you have learned in your electrochemistry last year chapter. How do you write half equation? So for sodium, we start one by one. For sodium, I'm changing now to sodium 2 plus. So meaning what I'm doing, I'm donating the electron. I donate the electron. Where do I write the electron? It's after the arrow, right? So meaning it's here. Sorry, there's a mistake. There's a mistake here. Sodium plus. Accidentally write here 2 plus. It's sodium plus electron. Half equation, you don't bother. I know here got 2 sodium, but do not bother all about that. Half equation, you just write the transfer of electron or the gain of electron. The reason why you write half equation is you want to see whether the electron get donated or accepted. Over here, the equation is already balanced. One sodium atom, one sodium atom. Here the charges cancelled out because here 0 charge, right? Here also now cancel out 0. 0, 0 equal already. So this is the half equation for oxidation. This is the half equation for oxidation. Whereas for reduction, what is the half equation? What's the reduction half equation? If you notice, oxygen, will it accept or will it donate electron to become O2 negative? What will happen? It will accept the electron, right? Because here is 0 charge. Here become 2 negative. That means it accept the electron, and it's definitely the opposite of this. If this donate, this one definitely accept. Reduction is accepting electron. I accept electron, I become like this. But if you notice, the equation is not balanced. Here got 2 atom. Here only 1. So I balance the equation. But if you notice here only got negative 1 charge. This is considered negative 1 charge. But here 2 times 2 negative is 4 negative charge. Here is 4 negative charge. But here only 1 negative charge. What do I do to make it balance? What do I do? I put here a 4. So now the number of atoms is balanced as well as the charge is balanced. Here is also 4 negative. Here is also 4 negative. So it's balanced. So this is the half equation for reduction. Then they will ask you the ionic equation, the full ionic equation. How do you write the full ionic equation? Remember, I have taught you this in your electrochemistry. You must combine now these two. When you combine these two, you got to cancel the electron. You want to cancel the electron. But if you notice here, it's 4 electron. Here is only 1 electron. What do? I times here by 4. When I times here by 4, what do you think happened? It means it's actually 4 sodium, 4 Na plus 4 electron, right? So now can I cancel? Yes, I can cancel. Then I write it down. 4 Na plus O2 gives you 4 Na plus 2 O2 negative. Okay, so if you notice, the equations are all balanced. This equation is balanced if you notice. You see, 4 sodium, here oxygen is 2 oxygen, here so it's 2 oxygen. You want to check the charge, here 0, here 0, so meaning here is completely 0. Here is 4 plus, here is 4 minus, so also 0. So this is your ionic equation. Okay, so usually in essay question, what they will give you is, they give you like a type of scenario. From the scenario, they will ask you to write your observation. After you write your observation, then they ask you to write half equation for oxidation reduction. Then they ask you to write ionic equation. So for me to write oxidation half equation, reduction half equation, I need to first identify who's oxidation, who's reduction. That's why I write first the equation. Now you tell me, what is the observation here? What's your observation? Your sodium burns with what color? What is the color of the flame? You have learned this in your last year group 1 metal. Lithium will burn with red flame. Sodium will burn with yellow flame. And then you learn that potassium burns with purple flame, right? So you just say sodium burns with yellowish flame and a white oxide is produced. That's your observation. Then they will ask you to state which reactant has oxidized. So you see, sodium atom is oxidized to sodium ion. Oxygen molecule is reduced to oxide ion. Can you see the name? I didn't say oxygen molecule reduced to oxygen molecule. No, I say oxygen molecule reduced to oxide ion. Who is the reducing agent? Sodium element or sodium atom. Who's the oxidizing agent? Oxygen molecule. Can you look at the term that I'm using? So all that is important. Now this one actually you already learned last year in electrochemistry. So if you've forgotten, you got to revise back. I cannot be teaching again the same thing. Okay, so with oxygen done. Now let's go through an example for chlorine. With chlorine gas, how will it react? So let's say it's let's say now we use magnesium. Magnesium burns with chlorine. What will you get? You get magnesium chloride, right? You get this, right? Okay, is your equation balanced? Yes, one magnesium atom, two chlorine atom, here also two chlorine atom. Yeah, I'm just checking again. Okay, everything is fine. Now I want you to tell me which is the oxidizing, reducing. So you think, or you want to pause the video, pause, and then you think, and then you see if everything, the answer you get is correct or not. Okay, first start with writing the oxidation number. That's the easiest. Oxidation number for a pure element is 0. Pure molecule is 0, but here this is an ionic compound. So for magnesium is +2. For chlorine it's -1, but here got 2 atoms, so it's -2. Okay, Ken? This settle? Now, which one has gone through oxidation? If you notice, magnesium 0 become +2. So meaning this is my oxidation. This is actually the reducing agent. Chlorine will be reduction. Why? Oxidation number has decreases from 0 to -2. When they ask you to explain, you cannot just say the chlorine molecule is reduced to -2. Cannot. You must tell from what to what. So you're going to say the oxidation number of chlorine molecule has reduced from 0 to -2. So can you see how in detail I am? That's how you got to explain. Okay, this is the oxidizing agent. Okay, now you write the half equations. You write the half equation. When the question asks you to write the half equation and the ionic equation, meaning you have to start half equation for your oxidation, also for the reduction. Sometimes the question never specify, but you have to do everything. So half equation for oxidation, we go through one by one. For oxidation, how do you do? Magnesium become Mg2 plus, right? So meaning it has donated electron, plus 2 electron. Can you see the equation is balanced? One magnesium atom, here the charge is 0, 2 plus, 2 minus, the charges become 0. So it's balanced. Now for reduction half equation, chlorine 2 plus, it will accept electron, become chloride. But my equation is not balanced. So first I balance the atom. Balance first the atom, don't balance electron first, it will go wrong. Balance first the atom. When I balance the atom, it's already 2 atom, but I notice here got 2 negative charge, here only 1. So now here also -2, -2. It's balanced already. Okay, this is the half equation. This is the yes, correct. This is the half equation. Now ionic equation. Your ionic equation is a combination of these two. So I cancel the 2 electrons, same number of electron I can cancel. So my ionic equation will be Mg plus, come here, then go back here, plus, come here. Okay, if you are not sure if it is balanced or not, usually it's balanced lah, because you already balanced here, right? So usually it's balanced, but if still not sure, we'll just check. 1 Mg, 1 Mg, 2 chlorine atom, here also 2 chlorine atoms, so the atoms are balanced. Next you check on the charges. Here 0, here 0. Okay, so this is 0. 2 plus, here 2 minus, so the 2 plus 2 minus becomes 0. So both sides also 0. This is your ionic equation. Okay, how do you Explain the observation. The magnesium burns brightly with chlorine, producing a white solid. Okay, so that is the combustion of metals with oxygen and chlorine. If they ask you to do, if they ask questions about redox reaction, this is the answers. Usually these are the type of questions they are asked both in structure and essay. I did give you one assignment. Later you will see there will be one assignment, essay, about 6 marks if I'm not mistaken. So you are required to write observation, equations. So you actually the answers is based on like this. Okay? Okay? Okay. Now the second part I want to teach you is the conversion of this. Okay, this is a bit heavy. Maybe what I can do is I'll teach you in the next video or the next lesson, because I don't want you to get confused with what you learn now. I will explain in the next video.